Today we are going to learn 2-3 trees. So what are they? First we need to know. So in a simple way I can say the node or node will be here and in 2 tree, and there will be 2 keys for this. So one key should be less than this and one key should be greater than this. The key value should be left hand side, it will be less than this node, right hand side it will be more than this node in 2 tree. And if we talk about 3 tree, so here what will be the condition? If suppose 2 nodes are there here, we can say 2 nodes are here. So the key value will be, the first one will be less than k1 and the middle one will be between k1 and k2 and the third one will be, first one will be less than k1, middle one will be between k1 and k2 and the third one, or you can say last one, will be greater than k2. The node value will be greater than k2 key node. So in that way we can say this is 3 tree and in that way it is 2 tree. So suppose we are going to take one example so that it will be easy to understand. So suppose first we are taking the 9, the node value is 9, and after that, so it will remain same, no problem. After that, suppose we are taking 5 also, so 5 9, right? So it will also remain same, 2 values. Now again suppose if it is 5 8 9, suppose there are 3 nodes, so we need to split it. We need to split it because 3 nodes are there and we can't put 3 nodes because in 2 tree 1 node is enough, in 3 tree 2 nodes are enough, but in 2 or 3 trees 3 nodes can't be possible in a single node. So we need to break it. So how we will break it? As we are able to see here from this 2 tree, the node will be like this. The one node value will be less than this and one node value more than this. So what we will do, we will split like this. We will put 8 here and we will put 5 here and we will put 9 here. So you can say the node value from 2 tree, it is node value and the key value is less than this, it is on left hand side, and more than this it is on right hand side. So it is okay. So we can say it is 2 tree. Now suppose if we are adding 3 in it, if we are adding another node 3 in it, so what it will be? It will be 8 3 5. Why? Because 3 is less than 8, so it will come over here, and 9 will come over here, no problem. No need to do any modification, simply it will come over here. So suppose now we are adding 5, suppose 3 is here, 5 is here. Now suppose we are adding 2, suppose we are adding 2 in this tree. So how we will add 2? Again it is less than 8, so it will come over here. So we will write here like this: 2 3 5 and 9, 2 3 5 and 9. So till now condition is okay, 2 node can be possible like here in 3 tree, but now we are able to see because maximum is 3 node at one point, so we can't make it, so we need to break it again. So what we will do here, the first and important thing is here, 2 3 tree always grow in upward direction, not in downward direction, always grow in upward direction. So we are here again, we need to break it. So how we will break it? We can make it 3 tree node. So 2 nodes will be up and rest 3 nodes will be down here, as we are able to see. So we need to make one node up. So we need to choose the node like this, that in between one node can come. In between these two values, one node can come. So we need to choose 3 here, because if we put 3 over here, so between 3 and 8, what value is there? 5 value can come. We can't choose 2, because if we choose 2, so there is no value less than 2. So we can't choose 2. And 5, if we choose 5, fine, then 2 3 node will come over here. So no node can come in between. While this is the condition of 3 tree, then the nodes will be split like this. So that's why we need to take 3 up. So we are taking 3 up. So we are writing here. After this we are writing 3 8. From here 3 8 we are writing. So 3 will go up. 9 will remain same as it is. So 9 will come on right hand side. And 2 will come on left hand side because 2 is less than 3. So 2 will come on left hand side and 5 will come between 3 and 5. 3 and 8. What will come? 5 will come. So like this we can do. Now again, suppose if we are adding 4. Suppose if we are adding 4. So what we will do, it will remain same, and we will write 2 here, and in between we can write 4, 5, because 4, 5 comes between 3 and 8. So it is okay, no problem. Now suppose if we are adding 7. Suppose if we are adding 7. So 7 will come over here because it comes between 3 and 8. So we will write like this: 3, 8, 2, 4, 5 and 7 and 9. Right? Till now it is okay, but now here again 3 values, but we can't have 3 values. We can have maximum 2 or minimum 1 value. So again we need to break it. Again we need to break it to make it 2, 3 trees. This is the condition of 2, 3 trees. So again we are going to break it. So what we will do, again we need to put one node up, so that left node will be less than that, between node will be middle node will be in between that, and the last node will be more than that. So again we are breaking it. So what we need to do, we need to put 5. We need to put 5. So we are putting 5 over here. So we are writing like this: 3, 5, 8. So 2 will come over here because 2 is less than 3, and 4 will come in between 4, 3 and 5, and 7 will come between 5 and 7, and 9 will come over here. So in this way we have breaked it. 3, 5, 8. We put 5 over up, and 2 and 4 will come between 3 and 5, and 7 will come between 5 and 8. But the thing is that again it's 3, so it can't be 3. It can't be 3 because this is not the condition of 2, 3 or 3, 3. So again we need to break it, and we will break it into upward direction. As I have said earlier, this tree can be converted into upward direction. So what we supposed to do, we need to put 5 up. We need to put 5 up. So after that what we are doing, we are putting 5 up. Then what will come over here? 3 is less than 5, so it will come over here. 9 is more than 5, so it will come on right hand side. Right? Then again 2, 4 are there. So 2 is less than 3, so it will come on left hand side. 4 is more than 3, so it will come on right hand side. And 7 is less than 9, so it will come on left hand side. Here 5 will not come, here 9 will not come, here 8 will come, because we have split this node. So 5 will go up, 3 will come left hand side, and 8 will come on right hand side. It's 8. So again 2 is less than 3, so 2 will come over here. 4 is more than 3, so it will come over here. 7 is less than 8, so it will come over here, and 9 is more than 8, so it will come on right hand side. So now it is perfect. Now it is perfect. So in this way we can make 2, 3 trees conversion. This is the way. So now I am discussing one more thing, that is lower and upper bound. Lower and upper bound. So what is this? It is log 3 for 3 tree, n plus 1 minus 1 less than equal to height of the tree. Less than equal to height of the tree. And height of the tree is less than equal to log 2 n plus 1 minus 1 for 2 tree. You see again carefully, if it is log base 3, then it is for 3 tree. If it is log base 2, then it is for 2 tree. So this is an lower and upper bound. So how it is working over here, we can see, we can put the value. If suppose we are putting the value of n is equal to 2 here. Suppose if we are putting the n value 2, so it will be log 3 and 2 plus 1, right? So 2 plus 1, 3. So log 3 base 3, so its value will be 1 and minus 1. So we can say the height is 0. Suppose if 3 nodes are there, or maximum 2 nodes are there, so we can see from here 2 or 3 nodes are there, then there is 0 level. 0 level we can say, height is 0, right? So in the similar way, if we increase the node number, so suppose if we are putting 8 plus 1, 9, right? If we are putting 8 nodes, 8 plus 1 is 9. So log 3, 9. So it will be 3. Its value will be 3. So 3 plus 1, 4. So we can say the level is accordingly. You can see here level. 1, 2, 3. How many nodes are there? 1, 2, 3, 4, 5, 6, 7. And maximum 9 node can be possible. Because if we are adding the two keys over here, 2 keys over here, so 1 node will come in between. This is the 3 tree condition, as we are able to see from this. So based on this, we can see here this is correct, and in the similar way we are putting the value of n, so we are getting the same formula for 2 tree also, because if we are putting n value as 1, then 1 plus 1 2, log 2 base 2 value is 1. So 1 minus 1 0, the height will be 0, and if 2 nodes are there, so we can say height is 0 over here. So if we are increasing the height, if we are increasing the number of nodes, so in that way the level will be increased and height will remain same. So this is the lower and upper bound for this tree. So we can say simply for insertion and deletion, because it's based on log n only, we are able to see everything is based on insertion and deletion, everything is based on log, because accordingly it is increasing and decreasing height based on log value, as we have taken the example, and in the similar way it will work over here. So if it, for an example, so for insertion and deletion, and for worst case and best case, for worst case and best case, in all the condition, its time complexity will be log n. Its time complexity will be order of log n, because everything is based on the height, and height is based on the log value. As we are able to see, depend upon the n value, it will give us the level, either 3 tree or 2 tree.